Hello and welcome to this Mastering the Machine Automation Academy webinar for the 26th of February 2022. The topic today was PLC templates and spreadsheets and tag generation, and I was pretty much the only attendee. I think a couple people stopped in, but wasn't able to talk to anybody. But there was lots of good information about this application that I am teaching next week for Automation NTH, and I hope you enjoy it. Hi folks, and welcome to this episode, this webinar for the Automation Academy Mastering the Machine. And today my camera is not working. I'm not really sure why. I've tried every camera on my computer and none of them seem to work. And rather than rebooting my computer, I've decided to just go without. I think there's a picture of some kind up there holding my place in Zoom. But in any case, I don't think anybody is logged in here yet. So I'm not even sure if anybody's going to attend today. But it is Saturday, and Saturday is kind of a tough time to get people to attend. It's 10 o'clock in the morning, Central Time. And today's topic is PLC tags and simulation. I'm going to be going into some pretty deep stuff today on a class that I'm holding next week. I had hoped to be able to show some things like my book, which I do have here, a new copy of my latest edition of an existing book, PLC Hardware and Programming. I did get a NTH University version of it published, and this is for Dexcom. They had wanted to be able to get large quantities of them, and they were having a hard time getting them from the old publisher, which was Author House. And so I decided to publish it myself. And the biggest difference between it and the old one kind of had a blue cover, and this new version has this logo that you see at the bottom of the screen here, where it says Automation NTH and NTH University. We'll get the advertising stuff out of the way here. What is Mastering the Machine? It is named after a 26-page document called Mastering the Machine that I wrote on machine specification about 8 or 9 years ago. And you can download it at the two sites that you see here, automationllc.com, which is my business site, and automationprimer.com, which is an old blog that I honestly don't keep up with very well anymore. In any case, on the automationllc.com site is a site called the Automation Academy. It's a membership site, and part of what I do here is try to advertise and get people to join that site. It has a lot of training material on it, and that's what this is all about, the Automation Academy. Training videos for Allen Bradley, Siemens, and Omron. I could create training videos for other things too. I do have software, etc., but these are the most popular platforms that I've run into, other than things like Codesys and Beckoff, which I don't do a lot with. So anyway, what's on the Automation Academy site is lots of videos, lots of written documents that you can download, technical documents. There is a community with interest groups, and we do have regular events. Every 2 weeks, I do these Mastering the Machine webinars, and sometimes people show up and hang out with me, but today, so far, nobody's here. Anyway, last week, well, 2 weeks ago, I guess, we talked about PLC tags and PLC templates. And I kind of talked about what is a PLC template. We're going to be going into a lot more depth on that today. A template is a basic PLC program that serves as a starting point for a project. So the class that I'm teaching next week, I'm going to give everybody a project that's already been started. It really doesn't have much, if any, code in it, but it does have a structure, and it might have a bunch of things already imported into it and ready to start. If you put too much code in there, then what people end up having to do is delete it, which makes it a little more difficult to follow. So it does save you a lot of development time, and it contains items that would be common to all programs. You don't want to put things in there that are particular to a specific application, because you'll just end up deleting them, and deleting things can be very difficult. There's a lot of searching for files and things that might be related to some of the things that were in there, and I'll talk a little more about that today. For Allen Bradley, this includes something that Allen Bradley is specific to Allen Bradley itself, called an add-on instruction, AOIs. For those of you who do Siemens, that's similar to a function block. It is a self-contained piece of code that you can call over and over again, and you can pass parameters into it and out of it. And then there's UDTs, which are common to pretty much all PLCs. They are structures, user-defined data types. And then there are EDS files, which again are kind of particular to Allen Bradley. Electronic data sheets, that is their method of getting third-party devices into their software. So for Siemens, which is another major platform that I cover, these would be the equivalent of your GSD files, which are generic system description files. But Allen Bradley, these three things are things that need to be imported into your program before you ever start your project. You can import them, I suppose, as you go too, but they would be part of a PLC template. Now, a little bit about this class that I'm teaching next week. This machine is a machine at Automation NTH that they use for trade shows. And what it does is it shows off a lot of the common features for something called a Flexbase. You can see the Flexbase sign up here, but Automation NTH builds these Flexbases and puts things like these robots and transport systems on the Flexbase, and you can move things around. And it's almost like a template for a machine. It gives you a starting place for a structure, and they give you a PLC with some of the code already in it. And that's what this class is based on. And the reason that I'm basing it on this class, well, there's several reasons. I'm going to show you something here. This is out of my next book. And at the end of my next book, I have a pretty elaborate troubleshooting exercise. I spend quite a bit of time in this book explaining what this machine does, right? So I have a lot of troubleshooting information here on this particular machine. There's another picture of it. I explain how that machine works. I talk about the PLC program, which is what you see here. I talk about the data structure that's in the template that's already there, right? Which is a lot of what you see here. And then I do start going over the electrical schematics. Let's see if we can find some schematics here. Remote IO block, there is a lot of IO. Let's see if we can get back to, there we go. There's a bunch of schematics. So I talk about a lot of the devices that they use on this machine. I go through the schematics pretty in depth, and there are a lot of kind of special purpose things. Here you see a bunch of IO link. IO link is a communication protocol that allows you to get more information than just the digital state of your sensors. So each of these sensors gets basically the health of the sensor also, and you can use this for analog or digital. These stack lights are IO link, and what you can do with them is create lots of different patterns and colors in your stack lights. That's kind of a neat feature of IO link. So I explain what IO link is. I go through the structure of this template, right, that they use for the Flexbase. So that's just a little bit about kind of where the idea for this simulation class kind of comes from. Now, as for the class itself, this is an intern PLC course. So the people that will be taking this class are interns and of Automation NTH, NTH University. This is a PLC course, as you can see here, starts on February 21st, which is Monday. and I go through very little bit of detail here. I give people a bunch of files. I give them this document. I give them an application document, which I'm going to show you in a minute. And that application document is based very much on a Flexbase, which is that machine that I showed you. I also give everybody a Excel tag generation document. I talk about how to generate tags in Excel. I give them a couple spreadsheets of those tags. I give them a couple of, I give them one empty program, and then I give them an emulation program. And there is a big difference here. So I'm going to kind of show you what those are too. And then I give them these PLC tech files, which include the AOIs that I talked about, the EDS files, the UDTs, things like that. Each one of them have folders, and in those folders are literally hundreds of files. So lots and lots of stuff. And then I start talking about the agenda, and a lot of the agenda, I'm going to be making it up as I go along. And the reason is I've taught this class probably 4 or 5 times over the last 3 or 4 years. I do sometimes 2 a year, and then of course COVID slowed things down a little bit, but I do at least 1 a year and have anywhere from I'd say 6 to 8 students. Usually I think I have 5 this time, and I talk about a lot of things in it. But in the past, when I've done these classes, they have been as an independent company. And this time now I do 2 weeks a month as an employee, a contractor for Automation NTH. So because I'm doing that, I'm really documenting this course a lot better and making it one of their NTH University formal courses. So as I go through this class, I will add to this document, which is the description of what the course will be. Okay, so that was the Intern PLC course document. I give them this sheet. This sheet explains what the tag generation spreadsheet is. I talk about things in here that they would already know about, like aliasing. I talk about deriving tags and things like that. They've already been through and they know what HMI push buttons are. They know what aliases are. They know what UDTs and add-on instructions are. So if you don't know what those things are, there's lots of ways to learn that. Of course, I have YouTube videos and I explain what all those are. We're not going to go into great depth on that today, but they would be expected to already know this stuff. So I talk about what is on all the worksheets, right? So here's a description of all that, and I'll be showing those. So you'll get to see kind of what they look like. This is just on the generation of the tags. And see what else we got here. I also give them an application. So this is a look at the application. I'm going to show a better picture because these are sideways, which for the students, that's okay. But for you, that would be really hard to read. So this is the application that I show them. And the pucks that I was going to show you, I have one of the pucks here. And of course, I'll hold this up for the students. But these pucks are passed through that suite machine, which is their trade show demo. And what they do with the pucks is they simply pass them around the machine, and then they have a little housing, and as the puck goes into the housing, there's a candy dispenser, and that's why they call this the suite machine. There's a candy dispenser that the puck goes in, a bunch of lights flash, and a roll of candy. Basically, it's Lifesavers comes out on the far end of the conveyor. So it just creates a little magical illusion, lots of flashing lights. A puck goes in and gets magically turned into a piece of candy. You notice that there is a black side of the puck and there is a orange side of the puck. And that has to do with what this simulated machine is going to do. So I say this is the top and the bottom of the puck. I talk about the transport, and this is directly off of the suite machine. So these are pictures of the sensors in the suite machine. This is a puck present photo eye, right? Everybody knows how a photo eye works, hopefully. It puts light out and either bounces off of a reflector or off of a receiver and tells you whether an object is present. So this is the puck present photo eye. And then there is a pallet present photo eye underneath the pallet as the pallet arrives with a puck riding on it possibly, and a pallet stop. So this explains a little of the physical part of it. And I talk a little bit about, again, how the conveyors work, how the elevators work. These are things that they could go into Automation NTH, go look at that machine, or they could read my book and they can see how that operates, right? Like I said, there's about 50 pages in my book that describe this machine in pretty good detail. So the stops and the robot and the elevators and all that operate just like this sweep machine. Lift and locate cylinders, these are on there also. What they do is they raise the pucks up and they center the puck. And so what I've done here is I've built a simulation that basically duplicates a lot of the functionality of this sweep machine. So what I did is, and we'll go ahead and go to another page here and I'll show you kind of the mapping of it. This is the layout of the simulation that they're going to be following here. So what you can see here is the left elevator raises up with an empty pallet, and the pallet moves over here into the bottomless location. And the puck is actually a solid, just like a hockey puck, but I'm simulating as if it's two halves. And so the idea behind this simulation is you dispense a bottom half, you put an RFID chip in it, you put some glue on the bottom half, and then you place a top on it. You're gluing the two pieces together. As you put the top on it and it raises, it also basically pushes the two pieces together. And I explain that in a little more detail in the application document itself. Then you inspect the puck and you look at the RFID tag itself, and you look at the color and you make sure that there's a top on it and things like that. If, for instance, you were to dispense a orange in the bottoms, right, then you would have two orange halves and you would want to inspect that and tell whether the part was bad or not, you know, wrong color or bad RFID chip or too much glue dripping down the side, whatever you want it to be. Of course, since this is a simulation, what I do that's kind of interesting, I think unique to PLC programming, is I give people, how do I write a random number generator? And I think I've done this online before, but when you do a random number generator, it gives you the ability to fail some percentage of your fake parts. We're simulating everything here. So if it fails, then you have a pick and place here, and you pick the part up and drop it into a reject bin. And again, I explain all these stations in the document that I give them. If the part passes, then in the last station, which happens to coincide with the elevator itself in the upper position, they pick up the puck, take it off the elevator and set it in a box. And then the box is basically a palletizer. And again, all simulation, none of this is real stuff. Here is a look at the transport system. These are each of the stations. And if you add the part present eyes and the lift and locates and all the stops that you see here, these little X's simulate sensors, right? Proxes, proximity switches on the cylinders themselves. So the lift and locate cylinders each have an up and down prox, and then the stop just has a up or down prox. And I forget which I did. I think it's a up, I believe. So what you do is when you withdraw the stop and the conveyor's running, you lower the lift and locate, and the pallet makes its way to the next station. So again, this kind of matches what you see here. So this is a side view of it with all the lift and locates. And you can see there is a stop down on the bottom, and this allows you to put, I believe I said that you can use a maximum of 9 parts within this simulation. Okay, so that's a general overview of what this would look like. This is the top view with all the palletizing, and this is the side view. right? So that's just a little bit of a look at that. Now let's go back to the document that I wrote up for them. So I go through each one of those stations and talk about exactly how they're going to program that station. I tell about what it does with the lift and locate. I draw a little simple picture. I have a little key here. And the first thing that they're going to do is they're going to assign all of this IO. They're going to need to create all of this in their PLC program. When they do that, it would take a really long time. And I'm going to go ahead and backspace this. There we go. D, put that, all right. So it would take a really long time to type all this in. So one of the things that you can do to make things faster, you see all the IO here. This is just a ton of stuff if you had to just go into your PLC program and type it in, right? Sensors, actuators, lots of outputs, lots of inputs. So what you can do to make this a little bit easier is you can create a spreadsheet. And again, this is why I gave people the instructions on how to use a spreadsheet. When you export tags from a PLC program, this is the format that it exports in. So if I were to create a bunch of tags in the PLC program and export them, they would show up in this form right here. And so what you want to do is if you have to re-import tags like this, you need to import them in this format, right? Or else the PLC program won't recognize the tags. So what I do is I give them this spreadsheet. Now this spreadsheet, you could create this pretty easily yourself. What I do here is I use in Excel what would be called, I suppose, concatenation. If I go to this tag, right, this is made from F3 and, right, putting this format in here and E3, and I create the alias for the tag and I create the tag name itself, right? And you can see this here, and then I create a description. Now, in a big tag spreadsheet, a lot of these things like this address and this description could be also used for AutoCAD. So if you're doing AutoCAD design of a system, it's really nice to be able to type all this stuff in one time and export it all. And so here's the inputs, here's the outputs, here's the analog inputs, the analog outputs. These are called derived tags. And for every input or every output, there are a lot of derived tags, right? So for instance, spare HMI push button, right? This would be the description for just the push buttons. For every valve, hypothetically, you could have a push button. So as you change this tag, right, as you add this particular tag, I'm gonna have things like, you know, these lift and locates. You would have a push button for each one of those lift and locates. You would have a raise push button and you would have a lower push button. Now you could combine those into one push button and use it and toggle between raise and lower. That's kind of up to you, but this is supposed to save you a lot of time, right, as you type things in. So that's what the derived tags are about. You would have push buttons, you would have permissives for those outputs, you would have faults for those outputs. Every output probably has a fault associated with it, right? So you would have the fault tag and you would have the fault description. So all of these things would be things that you would want to generate automatically. So these are just text versions of all these. And then I actually allow you to create the tags. Now, right now, this spreadsheet is, I haven't spent a lot of time creating it, but you get the idea behind it. What it does here is you copy these derived things here, these tags or whatever, into this format. So I can copy the descriptions into here. I can copy the tags into here. I can copy the aliases into here. And then you need to copy these all the way down. Now, because of that, right, Some of these I think are floats, and some of these are dints. Some of these are bools, and so the access and everything would be a little bit different. So what you're doing is you're building this structure so that you can import it back into the program. That's the idea behind it. Here's the IO list itself, right? So here's all of your tags and things that you would use for that, the alias, the base tag. This is in the format that the PLC program itself has. Here's some lists. These are lists of things that you could use to generate back here, these tags, right? I, PB. If I change the list, it would change the thing in the middle here, right? So some people may want a different format. So this is a kind of a work in progress, but it gives you the idea of how you can do things automatically in Excel that would take you a long time to do if you had to type everything into the PLC program. So that's a little look at the spreadsheet. Then I have the document that describes how to use the spreadsheet. I've got it aliased ahead of time to these addresses, digital inputs, digital outputs. And what I do here is, since it's simulated, I go ahead and make sim inputs and sim outputs. Now I'm going to show you a little bit of the PLC program itself. But before doing that, I'm going to show you the base program that emulation program is coming from. And we can't emulate everything that's in the base program. And part of the reason is, right, this uses a very specific PLC here. It's a safety PLC. It's in slot 0 because it's a compact logics, and this happens to be the type of PLC that they use on those Flexbases. So it has a whole lot of stuff in here that I can't put in the emulator. Like it's got Ethernet valve banks here. It's got an IO link master that is Ethernet connected, and then into the IO link master has a lot of digital IO. It's got a connection to some circuit breakers. It's got, I think, some analog on there. It's got a robot. It's got a camera. It's got a drive. So these are all things that you would like to see in a template, right? And this is, again, mapped off of the suite machine. So lots of safety IO, e-stops, things like that. So this is the base template, right? And this is not what they use at NTH, but it's something close that I'm going to use as an example for the students. I'm going to say, I got this off of the suite machine. So it kind of is something that they would normally use at Automation NTH. I didn't have a lot of this before because I was teaching their interns without having a lot of content, right? So now I have all this information. I've written, like I said, my book on it. It describes what all these things are. So hopefully people would understand what this program looked like. Now let's look at the other program. So the other program is based on that program. You'll see that the structure is the same. However, if I go down to the IO, it has an emulation. So what I'm doing here, and you can see it's actually running. I'm running this program in emulator version 30. Now, another difference, the computer that I'm using for this webinar has version 30 software on it. And when I start teaching this class, I'm going to be using version 31. It's pretty easy to take an older program and export it and then just simply change the processor to a version 31. It's not so easy to go backwards. You can export the program as an L5X file, and you can slowly kind of copy things into the program, but it's not as simple as going forward in revisions. So that's one of the complex things about Allen Bradley, is it's really kind of hard to go backwards. Pretty easy to go forwards, hard to go backwards. So because all I had was version 30, and that's the latest version I've got on this computer, I had to recreate this program. And just for practice, this morning, I filled out all of these routines, just like their suite machine routines. I added some of my own things. So an example is Automation NTH puts everything under what they call events. they say faults and events, you know, warnings and messages and things like that all fall into the same routine. In my experience, when I teach classes, a lot of maintenance people really want the faults called out separately, because that's where they go to find out problems with their machine. So I separated those, right? I made a little different structure here than Automation NTH uses. And I'm going to kind of lobby for them changing their structure too, because again, I get to see a lot of the end users and see what they're looking for. Now, the other thing that I've done here is created a very simple system routine, which I've done on YouTube before and kind of showed everybody how all this works. It's basically auto and manual mode within auto cycle start. And it took creating all of these tags to make that work. This tag, right, you see here, there's a UDT here that was imported, and that is UDT base configuration. This goes to Automation NTH's structure where they have this Flexbase. So I made sure that was in the template, even though I don't think I'm going to use it. Now, what does it look like? It's got a left elevator, a right elevator, things like that. I'm going to show everybody this thing, but I'm not necessarily going to say that students should use it, because I don't really know what its purpose is. So without looking at the Sweet Machine program, I couldn't tell you why they had created this in here. But in any case, the rest of the tags I had to create. Now, one of the things, back to the spreadsheet. Let me pull a spreadsheet over here again. Okay, here is a spreadsheet, and you will see some aliases. So I am aliasing to sim digital input 0, sim digital input whatever, and you type in your tag names here. It generates the description, it generates the tag name, and it generates it in the field that would have the simulated digital input. Well, to be able to do this, you're going to export this and say alias it to something. You needed to have these tags in there already to alias it to, right? So you can see here, sim digital input is 8 double integers. Each of the double integers, of course, has 32 bits in it. So this is what I am aliasing to. But if I were to import this without having the tags that I'm aliasing it to in my template, it wouldn't work. So I have to have these in there ahead of time. I have not imported any of these tags yet. I've just kind of written a little bit of a simulation of the auto and manual mode and that sort of thing. So a little look at what I've got in the program so far. There's not really a lot to it. One of the things that I allow people to do is, right now you can go into auto cycle if you're in auto mode, but there's nothing to stop you from doing this, for instance, right? And this would be bad. You would not want to be able to flip into manual mode while you were in auto cycle. So one of the changes that I would want to make here, and I'm going to show you how to make that. I'm going to toggle the bit and put it back in auto mode, is to say, if you are in auto cycle, I do not want to, okay, so we're going to go into edit mode here, start pinning rung edits. And if you are in auto cycle, which was this down here, I do not want you to be able to go into manual mode. So I'm going to edit this real quick. It's a nice thing about Allen Bradley. You can just drag things, drag and drop. Right, so this says if I push the manual push button and I'm in auto cycle, it will not go into manual mode. So this is an emulator. It's not a real PLC, but that would work, right? So now if I toggle this bit, you can see I can't go into manual mode. So that should be part of the template, right? If I'm going to give people the auto control, auto and manual mode, then I also need to give them all the correct code for it. Now, I saw that somebody showed up a while ago and they left during the webinar, and that's probably normal. They didn't say anything. And of course, people know they can pick this up on YouTube later. or they just may not have been very interested in it, and that's fine too. So I don't have any guests today. I don't have any anybody attending this webinar. So I'm probably going to be able to end it right at 11 o'clock because, you know, there's nobody here, which is cool. But anyway, so how does this work? I've kind of talked about this before. This is a pretty typical auto manual, you know, mode type thing. To go into auto cycle here, let's go ahead and do a cycle stop. To do that, I need a cycle stop permissive, and then I can do a cycle stop request. It immediately requested it. The request unlatched auto cycle, and I'm back here, and I can turn this off. And the reason I want to turn this off, if I go back into auto cycle and I was still pushing the cycle stop push button, I would get another cycle stop request. The cycle stop permissive would be on, and I would unlatch cycle stop or auto cycle immediately. So how does auto cycle work? You push a button, right? I'm in the process of starting. I've got a request, and I go into auto cycle. Then I let go of the push button. So this is a little bit on the simulation part, right? How do I simulate auto and manual mode? How do I simulate auto cycle? Notice they are not in the simulation routine here. So I have a simulation routine in all of these in this template. And what I'm going to put in that simulation routine is things like, if I go down and I look at these add-on instructions, I've got an actuator simulator. And what that would do is I could take an output into the front end of that and generate an input on the back side of it. So let's say I have a pusher and I actuate the pusher, and I'm just going to simulate how long that pusher takes to reach its extended procs. So what kind of things would I have? Let's take a quick look at that, and I can put one, create a tag and use an add-on instruction, right? Here's the add-ons, by the way. Let's see. Got to go in here where we can grab them. There's all the add-ons. There are a ton of add-ons already in here. And one of the things that I've done is Automation NTH generally puts this capital AOI in front of their add-on instructions, and I use a lowercase a. So all these were imported right from my add-ons, and then the rest of these were from Automation NTH's add-ons. Now, to give you an idea, and I showed this in the last webinar, of what kind of files are in here, right? These are a list of all of the add-on instructions. And I've written down what some of them do. You saw AI handler here. AI handler is analog input conditioning. That's an add-on instruction that works with every analog input. DI handler works for digital input conditioning. And again, the students are very familiar with DI handler because they've done an exercise that used that in it. My add-ons are down here, and I didn't have the lowercase a's in them. But when I imported them, I made sure that the lowercase a was in front of it, right? So these are my add-ons. These are Automation NTH's add-ons. And I mentioned during the last webinar, I believe these are Alan Bradley's add-ons. I think they're time calculation add-ons that you can probably get straight from Alan Bradley. And that's why the T underscore is in the front of it. Some of these other things, some pretty complicated stuff here. Parse strings as separated by a delimiter to the output string array members. If you decide that your delimiter is a comma, for instance, you can do comma delimited files, take apart text messages and build them into whatever you want them to be. There's a PF PowerFlex 525 faceplate add-on instruction. If somebody wants to use it, it would be there. So these files are also things that I'm going to give to the students. If it was a real application, you could also use these EDS files and build the structure that I was showing before with the safety PLC and all the extra devices, right? There's an SMC valve bank. Here's some Cognex stuff that would be in the add-on profiles right here. Integration with RS Logix. And here's all the UDTs that we talked about. And as you can see, there are 110 UDTs, of which some of them are, again, are mine. There's even 2 here from American Beverage Depot where I do a lot of work, and I've done some webinars talking about them. So these lowercase u's are ones that I use. The UDT, lowercase UDT, are Automation NTHs, right? And where I found them. So this would be important stuff. This is all stuff that I'm going to show these students. Some of them I found in the Sweet Machine. Some of them I found in their revision 7 of their template. Some of them were in both. So I'm going to spend a lot of time explaining that to the students also. So they will get a USB stick with all of these files on them: add-on profiles, AOIs, this list, right? This PLC Tech Files spreadsheet list. They're going to get all that as part of the class. So I'll just give everybody a USB stick. I'll tell them to copy all that onto their computer, and they're all using version 31. So I will give them a version 31 program, and it'll have some stuff already pre-done, kind of like this. And then probably I'm going to have them write this code themselves. And I'm going to explain the fact that you could build all this into a UDT. You could build all this into an AOI if you wanted to, and make it all a package, make it all a standard for yourself. Now, I can't guarantee that their standard would be the same as NTH's standard. So that's one of the things that we're going to talk about. So the idea behind this class, this is a 5-day class. Again, I've done 1 to 2 of these a year since about 2017, probably 2018. These are young engineers that already know how to program, have been through some of the exercises at Automation NTH, using ControlLogix, using RS Logix 500, and often they have also designed their own control panels. They've worked in the panel shop, so they know what things like the proxies and the photo eyes and things like that are, right? So that is the general idea behind right, these PLC templates, these spreadsheets, and having this application that they're going to use here. So that is basically what I'm doing, right? Teaching this class next week to Automation NTH. Last week, I was in Baltimore, and I taught a Williams Gas, and they are a basically natural gas pipeline company, right? So they have compressors and pumps and things like that for natural gas, very specific type of industry. And we spent 4 days in a ControlLogix class for automation training and went over things particular to their industry. So I wouldn't use a template like this, because things like pick and places and lift and locate systems and robots make no sense to people who work in that kind of industry. So we had some interesting conversations, for instance, about safety systems, and they don't even use dual channel e-stop circuits, which I was kind of surprised to hear. But when you think about it, most of their safety is handled in a different way. When you hit the e-stop in those companies, you're really not necessarily protecting personnel. You may be shutting down the system, but they have further safety systems behind those, I'm sure, that probably supersede the dual channel circuits that we're used to. But for instance, this simulation, you see here, there's 2 e-stops and there's some guard doors and things like that. To be able to design these kind of circuits, you need to know a lot about dual channel circuits. And so I'm going to go into some pretty good detail on the electrical circuits for these. And of course, I'll use examples from here, right, where I go into a pretty good amount of detail on safety circuits. I actually have a section in this book on machine safety, and I also cover the safety circuits in the Safety PLC. All right, so this is a lot of what you'd be looking at. I go through, valves and different things like that, the actuators, flow controls. So there's a section on pneumatics. There's quite a bit on safety. There is quite a bit on how do their conveyors work, how do their start-stop circuits work. I'm probably not going to give them, pieces of this book yet, because I would have a hard time printing it, and they would, people don't like to just read stuff necessarily to learn. But I would say possibly my next class, maybe I'll talk more about this, and maybe I'll give them a copy of the book or an excerpt from the book and talk more about the safety systems, right? This is something I can't run on this emulator anyway. At least I haven't found a way to do it yet, because when you do the emulator, you lose a lot of this Ethernet. And this Ethernet was .io, it was safety .io, and I could, of course, build some safety circuits and things and simulate it pretty well, but I haven't set that up yet. So that's a lot of what you're looking at here is the write-up on the electrical part, control IO, .io, even some of their cameras and their communications. So this is, again, this is a look at my the book that I've just kind of mostly finished writing. There's a lot in here on everything from multimeters to tools to troubleshooting. And I go way back here, I go to safety systems, data manipulation. There's a lot of PLC stuff in there, right? Just like my newest little book. So that's what the book part's about. There's some stuff on robotics in here. And I was trying to find the safety section. I'm not finding it. There's machine vision systems. So of course, if you connect with me on LinkedIn, or if you look on my YouTube channel, you'll probably get a link to a lot of this. Variable frequency drives. There we go. There's the safety systems. This is kind of what I was looking for. Category 3, category 2, safety, PLR categories. This is by no means a full description of how these safety systems work, but it does give people a little bit of the background of the old stuff and the new stuff and how it all interfaces and a little bit of how to design them, how the circuits work. That's what all this is. So that's the basis behind this material. And as you can see here, there is a lot to learn before you ever get to the point where you can program a machine like this. You need to know safety circuits. You need to know a little bit about machine vision. You need to know a little bit about, motors and variable frequency drives. This is very much an engineering level topic. So some maintenance people actually are fully capable of doing this, but they've learned all that material from somewhere else. So that is the simulation. Will they get done with this all this week? I doubt it, right? You can't write a full program and simulate it, right? Which takes even longer than writing the full program in a week. It actually takes months to do that. But what I will do is they will have the basic template, and they will have a program started, and they can continue this program kind of on their own time and learn something from it. And hopefully it'll be the basis of something that they can continue education on. So that's kind of my goal with this class. And again, just to look at that system. And this is what they're going to be writing the simulation on. You've seen a little of the PLC program. You've seen a little of the Excel spreadsheets and things that go into this, and a little bit of my book that explains some of that. So that is pretty much the topic that I wanted to cover today, is PLC tags and simulation. And again, this will be the class that I'll be teaching next week. Week after that, I immediately have to teach a class in Atlanta, and it's a basic control logics class for automation training again. And this time I know I'll have a student from a truss manufacturing company, and I think there's some Navy guys and some Army guys there. And I'm not sure, you know, I find out every time I teach these classes, I go find out a little more about what the people in the classes do. So I don't know yet exactly what they're going to be working on, or, you know, what the topic of their learning is. So I'll ask them, and of course we'll be teaching in particularly whatever they're trying to learn. I think I've got 6 students down there. But in any case, that is the end of this webinar. I hope people kind of got something out of it. This is a pretty advanced topic. Like I said, there's a lot of terms in here that probably people aren't necessarily familiar with. AOIs and EDS files, and, you know, simulation and tag importing and exporting. That's just a little bit of a look ahead of time at what that stuff is. It does look like somebody else has joined me here. I see somebody else. Anybody I know there? Hello? Yeah, somebody's lurking here. Again, my camera doesn't work today, so that's why I'm not appearing my ugly face in the webinar. My camera somehow just decided to take a dump, so it didn't work. But if there's anybody there, any questions about anything I covered? I realize probably most people weren't here during most of the webinar anyway. The next webinar, I don't know yet whether it's going to be March 11th or 12th, but it's in 2 weeks. And again, usually I've done these on Fridays in the past, and it will be on either Friday or Saturday. Of course, I will post this on YouTube. So I have all these webinars on there. I think there's now 30 plus of these webinars that I do every 2 weeks. There's some pretty good ones on there. Some things on PLC Next. I've had different guests and things on there, and we've had a pretty good time in a lot of these. The last few webinars, it's just been me, and part of that's because I'm traveling so much that it's just really hard to set up guests ahead of time, and I'm gone all week, and hard to interface with people. But in any case, that is pretty much the end of this webinar. For whatever reason, like I said, my camera didn't work, and let me try it again. Still doesn't work. It just gives me a message saying doesn't work. So we will see you all next time. And if you watch the webinar, if you catch it later, I hope you enjoyed it. We'll see you later.